Hey everyone and welcome back to my channel. In this video I'm going to show you how to export a 3D model from SolidWorks into URDF format. First of all, what is a URDF file? Well, the Unified Rhombus Description Format, or URDF, describes your rhombus physical structure, things like its dimensions, joints, links and even sensors. Without it, ROS2 wouldn't know how your rhombus looks or moves, making tasks like simulation and navigation impossible. More specifically, links represent the rigid parts of the robot, like its chassis, wheels or arms, while joints define how these links connect and move relative to each other, such as rotational, prismatic or fixed motion. Together, links and joints form the kinematic chain of the robot, which is essential for simulation and control in ROS2. If you want to learn more about URDF, check out the links in the description below. Here is a challenge. Writing a URDF file from scratch can be very time consuming and error prone, especially for rhombus with many parts. Luckily, SolidWorks has a plugin that allows us to generate a URDF file automatically from our 3D model. This saves hours of manual work and ensures that the exported file aligns perfectly with our 3D design. It's a huge time saver, especially for beginners and complex robots. That said, the file generated by the plugin isn't ready to be used in ROS2 straight out of the box. There are a few tweaks and adjustments that we need to make for compatibility, and I will be covering those in this video as well. Before starting the actual process, I want to give you a brief description of the steps we are going to follow so you will get an initial idea of what is needed to create the URDF file. First, we need to create a point for every link of our robot. This point will act as the origin of that link's coordinate system. Then, if that link rotates along an axis, if it's a wheel for example, we need to generate that axis as well. Then, we create a coordinate system for every link. Lastly, we export the URDF file using the plugin by defining the relation between each link and the physical properties of the robot. Let's go ahead and see the whole process in practice. The first step is to download and install the plugin by following the link in the description. I already have it installed on my computer, so I will skip this step, but you go ahead with the installation. Next, open the assembly of the robot in SolidWorks as I'm showing you here. As I mentioned earlier, I need to create a point for every link of my robot so I can later fix a coordinate system at that point. Usually, we use the center point feature for this task. I will start with the chassis link. Note that this link will include the motors and the covers of my robot as well, as those components are considered to be part of the chassis and I no need to refer to them individually. Generally, it is a good idea to keep your robot model as simple as possible before converting it into URDF. For example, the robot includes batteries, electronics, etc. But since all of those parts can be considered one with the chassis, there is no need to include them in the URDF model. Next, I will create center points for the two driven wheels, the two castor wheels, and the LiDAR. After that, I will create the axes that my wheels are rotating about. We need those axes in a later step. Finally, I will attach a coordinate system at each center point. As you can see here, this is the coordinate system I chose for my chassis. The axis direction can be chosen randomly, but it's a good idea to keep a convention that makes sense to you and possibly the team you are working with. For example, I chose the axis of my wheels so that when they are rotating about the positive z-axis, the robot will move forwards. After finishing up with the preparation of the model, we will open the plugin. Go to Tools and scroll down until you find Export as URDF. Here, we will define the name of our links as we want them to appear in the final file, and we will define the connections between them. A URDF file is structured as a tree of links connected by joins, where the parent link defines the reference frame, and each child link is attached through a join that specifies the type of connection and its axis of motion. This architecture allows ROS to understand the rhombus kinematic structure. So, starting with the chassis link, I named it appropriately and then I chose its coordinate system. Next, I'm choosing the parts that I want to include in this link. Then, I will define the number of children for this link. I chose 5 because I have 2 driven wheels, 2 castor wheels, and the lidar, which are all children of the chassis. Next, I will define the link for my left wheel. In addition to defining its coordinate system, we also need to define the type of join that connects the child link to its parent. Because the join is continuous, we also need to define the axis at which the wheel is rotating about. I will do the same process for the right wheel as well. For the remaining 3 parts, the joint type is fixed as they don't move or rotate in relation to the chassis, and there is no need to define a reference axis. After setting everything up, click Preview and Export. Here you get to define some parameters that depend on your rhombus properties and dynamics, such as mass and damping. Finally, press Export URDF and Meshes. This image provides a quick recap of the process, and you can use it as a reference while working on your model. After exporting, we need to modify some stuff so that the file can work with ROS2. First of all, remove all the unnecessary files as I'm showing you here. Then, rename your URDF file to robot description. Go ahead and open that file. Remove the encoding. We also need to add an empty base link to the URDF so that the robot has a single root reference frame. This is important because in ROS2 the base link is commonly used as the standard starting point for all transformations. Without it, the rhombus transformation tree will not connect properly to the other frames like Autumn or Map, making it difficult to localize and control the robot. Then, add a join for our chassis and select the base link as the parent of the chassis. Modify the location of your meshes so that ROS2 can locate them properly. Here you have to insert the name of the package that the meshes are located in. Now I will switch to Linux to check that everything works correctly. I created a simple package that we can use to check that our URDF is loaded properly. I will provide the link for the package in the description. Open a workspace and place its package inside. Then just replace the URDF and meshes folders with the ones for your robot. Build the workspace, source the install file, and run the following launch command to open RVs and the Joint State Publisher GUI. By using this setup, you can visualize the robot model and test the joints. And basically, that's it. I hope you found this video helpful. If you have any questions or ideas for future videos, just drop them in the comments down below. Thanks for watching and see you next time.